students, I am coming up with short tricks, and today is the short trick number 1. Today we will learn about the null point. First of all, what is the null point? Actually, the null point is a point where the net electric field intensity is 0 in a system of charges. For example, now we will take up case 1 where the system of like charges are considered. When I say like, both the charges either positive or negative. So null point means the total electric field or the net electric field at that point should be equal to 0. Now if we take up the like charges, this is positive, this is also positive, Q1 is positive, Q2 is also positive. In the system of like charges, the null point lies in between the line joining the two charges. In between the line joining the two charges. Suppose if I choose this point P as the null point, notice that at this point the electric field due to Q1 is in this direction. We call that one as E1. And at the same point P, the electric field due to this positive charge is in this direction, and we will call that as E2. Notice that E1 and E2 are opposite in directions. Because they are opposite in direction, there is a chance that the total electric field will become equal to 0. So therefore, I choose the point P to be a null point. Always remember, the null point will be nearer to the weaker charge, and I am considering Q1 as the weaker charge and Q2 is the stronger charge. When I say weaker and stronger, I mean the magnitude of the charge. So Q1 is weak in magnitude, Q2 is strong in magnitude of the charge. Consider the magnitude of the charge only, not the sign. Now, notice that at null point, the total electric field should be equal to 0. Because the total electric field should be equal to 0, the electric field due to Q1 should be equal to the electric field due to Q2. That means E1 must be equal to E2. So here E1 is equal to 1 by 4 pi epsilon naught Q1 divided by x square. Look at this distance x. I have written K. K is 1 by 4 pi epsilon naught. That should be equal to the electric field produced at the point P due to the charge Q2. Therefore, K Q2 divided by D minus x whole square. So at null point, both the electric fields should be equal, and of course they are opposite. And therefore, the electric field, net electric field at the point P becomes equal to 0. Now notice that K and K will cancel. What remains is Q1 by x square is equal to Q2 divided by D minus x whole square. Now suppose if you rearrange the equation, D minus x divided by x is equal to square root of Q2 by Q1. And if you simplify, you will get d by x minus 1 is equal to square root of Q2 by Q1. And d by x, shifting minus 1 to the other side, you will get this. And you reverse this, you will now get x by d is equal to 1 divided by square root of Q2 by Q1 plus 1. And x is equal to d divided by square root of Q2 by Q1 plus 1. Please remember, here x is the distance of the null point. Here x is the distance of the null point from the weaker charge. Distance of the null point from the weaker charge. Now we have considered Q1 to be the weaker charge and Q2 be the stronger charge. D is the distance between the two charges. So x is the distance of the null point from the weaker charge. D is the distance between the two charges. So therefore, we get this equation. So therefore, remember this shortcut, always it is useful. X is equal to d divided by square root of Q2 by Q1 plus 1. Remember, here you should consider only the magnitude of the charge. Do not consider the sign of the charge. This is the equation you have to follow. And in the next session, I will come up with the next short trick. Goodbye.